Hello everyone, good day and welcome to this class. And in this class, we are going to start from chapter 1. I think this is chapter 1. And this topic here is electrostatics, right? Electrostatics. So, first of all, let us talk about what electromagnetism is all about. Electromagnetism is the study of the interaction of electric and magnetic field, right? And this interaction um, result from stationary or moving charges. So this interaction result from what? Result from stationary or moving charges. So which means that the study of charges is very important in this course. And the study of charges or the behavior of charge that is at rest is called electrostatic. So electrostatic is the study of charge at rest. You can write that down. Make sure you jot this. Electrostatic is the study of charge at rest, right? Now, what is this charge? What is this charge? Charge is an intrinsic property at which matter is made up. Charge is an intrinsic property, according to your inventor's book, in which matter is made up. We know from the atomic theory that all matter is made up of atoms, right? Now let us say this is a matter, denoted by M. Then these are atoms. Those small dots are atoms. Now if I go into the atom, right? According to Rutherford model for simplicity, we know that we have electron here. There is an electron revolving around the atom, and inside the atom, there is a nucleus, right? And this nucleus consists of what? Proton, right? And neutron, right? Now the proton is positively charged, while the neutron has no charge. The neutron has zero charge. And the electron is negatively charged. So we discover that positive and negative charge are inside the atom, and the atom are particles that made up the matter, which means that all matter has charges, which means that charges is an intrinsic property of matter, which means charges are what? Intrinsic property of matter. Now we have understood the definition of charges, right? Charges are intrinsic property of matter, and the reason is because all matters are made up of atoms, and inside an atom, subatomic particles, we have protons and electrons, which are positive and negative charge. All right. Okay, now the next presentation we'll be going into is ionization. Now, what is ionization? Ionization. When a material, are we there? When a material loses electron, it becomes positively charged. You can write that down. And when it gains electron, it becomes negatively charged. So the process of losing or gaining electron to become charged, either positively charged or negatively charged, at least the material is charged, is called ionization. Right? Okay. Now inside the proton, we make sure this class is as short as possible. Inside the proton, we just explained just now, we have inside the proton, inside the atom, according to Rutherford model, here is the electron, right? The electron have negative charge, and here is the nucleus having both positive, that is proton, and neutron. Now we know that the mass of the electron is far, far lesser than the mass of the proton and neutron. So which means that the mass of the atom, denoted by Z, is equal to the number of protons plus what? The number of neutrons. So because the mass of the electron is far, 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 far less than the mass of the proton and neutron. So the atomic number Z is equal to the number of proton and neutron. We know this from O-level chemistry and physics. All right, the next presentation we'll be going to now is called the fundamental principle of charges. Now, in this fundamental principle of charges, we have two principles. The first principle here is the principle of charge conservation, and the next principle is called the principle of charge quantization. But first, let us go into the principle of charge conservation. All right. Now, what is the principle of charge conservation? The principle of charge conservation states that the algebraic sum of charges in any closed system is equal to 0, right? So it means that the algebraic sum of static charges in any closed system is equal to 0. Now, let us take a neutron, for example. When a neutron, are we there? When a neutron, we know proton and neutron, right? Now, when a neutron separates from neutrons, because we know that neutrons have 0 charge. Now, when one neutron is separated from numbers of neutrons, to maintain that 0 charge, what will happen is that it will decay. We know this from radioactivity. It will decay into a proton and electron, right? It decay into proton and electron. Now we know that this proton is what? Is +1, that is positive charge, and this electron is negative, that is -1, right? So +1 minus 1 is equal to 0. And in this part, we know that neutron as what? Neutron are negative. Neutron are chargeless. They have 0 charge. So this is 0, which means that the number of charges did not change. It is still equal to 0. This is the principle of what? Charge conservation. In the next presentation, we'll be talking about the principle of charge quantization, and we'll also be talking about quarks. Still on electrostatics. Remember, we are trying to keep the video as short as possible so that it will be interesting and easy to follow up. Thank you very much. Make sure you subscribe to this channel and invite your friends and loved ones. We'll be covering this course from chapter 1 to chapter 13, everything free of charge. God bless you. Have a nice day.